I'm going to start with your central tendency homework. Remember, central tendency is just a really fancy way to say mean, median, and mode, which you guys have been doing forever. We had to do 3, 4, 13, and 14. Remember, you need to consider the frequencies. The frequency tells you how many times each data point is happening. Alright, it's a very nice way to write things. It's a very short way to write things. So, for instance, for number 3, if I have 5 happening 6 times, it's a lot easier to write 5 times 6 than it is to write 5 plus 5 plus 5 plus 5 plus 5 plus 5. Anyways, first thing I need to do is find the mean. Remember, the symbol for mean is x with a bar over it. To do that, I'm going to add up all of my data. So we're going to use the convenient way of 5 times 6 plus 4 times 10 plus 3 times 15 plus 2 times 11 plus 1 times 2 plus 0 times 1 all over how many data points you have. How many data points you have, you add up all the frequencies because that's how many people you asked. And that is going to be 45. Put that in your calculator. It's going to be 139 over 45, which is 3.08 repeating. Alrighty. Median is the middle number. Alright, the middle number of 45 terms. The middle number of 45 terms is going to be your 23rd term. Alright, if you think about it, we can take 45. 45 is odd, so we're going to have our little oddball in the middle. And then I've got 22 on that side and 22 on that side. So that's going to be my 23rd term. Alright, my 23rd term, if you can think about it, well, my first 6 terms are 5s. Then when I go up to my 16th term, those are going to be 4s. So my 23rd term is going to be a 3. So the answer is 3. And then mode is what happens the most. Looking at that data, 3 is definitely happening the most. It's happening 15 times. Number 4, we're going to do the same way. First thing you got to find is the mean, x with a bar over it. We are going to do 50 times 8, 40 times 12, 30 times 17, 20 times 10, 10 times 3. I think that's it. All over your n, how many things you surveyed, add up all the frequencies. In this case, it is 50. You are going to get 1, I'm sorry, why did that 1 look like a 7? Whoops. 16, 20, all over 50, which is a very nice 32.4. That is your mean. Next, to find the median, you got to be a little careful. Alright, 50 terms, that means I have an even number of terms. If I took 50 and I divided it, there is no middle. I'm going to have an even 25 on that side and an even 25 on that side. Alright, so remember, if there ever isn't a middle, we take the average of the two things that are in the middle. So really, if we want to keep going with this little diagram I have of medians, I want 24 terms over here, I want my 2 middle terms, and then I want 24 other terms over here. So I want the 25th term and the 26th term averaged together. Looking at this data, my 25th term is going to be a 30. So 30 plus 30 divided by 2, guess what? That's 30. So my median is 30. Mode is what happens the most. The mode for that data is 30. Alrighty, going down to 13 and 14, they are a little different. Alright, this was the new part of central tendency. Here you're not just given a straight up x value. You are given an interval of x values. Remember, I said, we talked about, what is the best way to represent an interval? You take the middle of that interval. Alrighty? So for my first interval, 21 to 25, the middle of that interval is 23, so I'm going to use 23s. The middle of 16 and 20 is going to be 18. So that is what I will use. Midpoint of 11 and 15 is 13. Midpoint of 6 and 10 is 8. And the midpoint of 1 and 5 is 3. Other than that, this goes the exact same way that we did for 3 and 4. X bar will be 23 times 2, 18 times 3, 13 times 12, 8 times 6, and 3 times 1. I'm dividing by the number of terms that I have, so I add up my frequencies. That is going to be 24. That's 307 over 24. It says to round to the nearest 10th, so when you put that in your calculator, you will get 12.8. Right? I've got 24 terms. That's even, so there is no straight up middle number. It's very similar to number 4. So if you think about it, if I'm finding the middle of 24 terms, I want 11 terms. I'm going to add up the 2 middle terms, and then I want 11 more terms on the other side. So I need the 12th and the 13th term to average together. The 12th and the 13th term are going to come from 13. So 13 plus 13 over 2 is 13. That is your median. For number 14, you got to be careful finding the midpoints of these intervals. All right, these intervals are even. So you can do 100 plus 91 divided by 2, or you could just kind of see that the middle of this interval is going to be 95.5. The middle of this interval will be 85.5. This will be 75.5. This will be 65.5. I hope you are sensing a pattern. 55.5, 45.5. We're going to do it the exact same way that we've been doing it. 95.5 times 5. That's a ridiculous amount of 5s. 85.5, I don't know why I wrote an 8 right here, times 8. 75.5 times 10. 65.5 times 6. You can write 55.5 times 0 or not, that does not matter to me. And then 45.5 times 1. Add up all of the frequencies, that's how many things I have, that is 30. Put all of this in your calculator, you'll get 2,355 divided by 30, which is a very nice 78.5. If you think about that, that shouldn't be too shocking that our average was in the 71 to 80 range because I had 10 data points that were in that interval. Same thing with number 13. Shouldn't have been weird that my average was 12.8 when most of my data was between 11 and 15. And then to find the median for number 14, median's in the middle. I have 30 terms. 30, there is no middle because you've got 15 and 15. So instead, I'm going to break it into 14 and 14, and I want to average the 15th and 16th term. The 15th and 16th term are coming from 71 to 80. So 75.5 plus 75.5 divided by 2 gives you 75.5. That is your median. Like I said, this should not be too difficult because you guys have been finding mean, median, and mode for a very long time. We also had to do a little bit more of the ambiguous case. Alright, finding out how many triangles you can have. You had to do 4, 7, and 15. Number 4 gives us a triangle. Guys, I've said this before and I'll say it again. Do not worry about what your triangle looks like. As long as it has 3 sides, I don't care. It does not have to be accurate. Alright? Number 4 tells me that little a is 5, little b is 10, and the measure of angle A is 30. You have to use the law of sines. You do not have an included angle to use the law of cosines. You don't have an included angle to use area, nor does this problem even mention area. And I do not know that this is a right triangle, so I cannot use the Pythagorean theorem. You can only use the Pythagorean theorem if you are absolutely positive that this is a right triangle. So, let's use the law of sines. The sine of A over A will equal the sine of b over b. We can go ahead and cross multiply. 10 times the sine of 30 equals 5 times the sine of b. Divide both sides by 5. This is what I'm going to put into my calculator. 10 times the sine of 30 divided by 5. I get 1. That is what the sine of b is equal to. To actually find b, I will do the inverse sine of both sides, because an inverse and the original cancel each other out. Inverse sine of 1 will give you 90. So b is equal to 90 degrees. If b is equal to 90 degrees, we can figure out c is going to have to be equal to 60 degrees. All right, let's think about it. Sine of b being equal to 1. Sine is only equal to 1 in one place. All right, think of it. 90 does not have a reference angle because it is a quadrantal. So there is no second possibility to check. All right, there is only one triangle. Easy peasy. I'm going to erase this just so I can stay on this page that has the book. Alright, next we have to do number 7. Again, just draw a triangle. I don't care what it looks like, as long as it has 3 sides. They tell me that little c is 18, little b is 10, and the measure of angle C is 120. Okay, so this is definitely not an accurate triangle because C is for sure not an obtuse angle in my picture. Whatever. Alright, I don't know enough to use the law of cosines. It is asking me absolutely nothing about area, and I have no idea if this is a right triangle or not. So, we have to use the law of sines. The sine of C over C will equal the sine of b over b. Cross multiply. 10 times the sine of 120 will equal 18 times the sine of b. Divide both sides by 18. Put this in your calculator. It will tell you what the sine of b is equal to. 10 times sine 120 gives you some crazy decimal. Divide by 18. You should be getting something that's about 0.4811 blah blah blah. I don't care about the sine of b, I want b, so let's take the inverse sine of both sides. Inverse sine, second answer, you get about 29 degrees. Well, if b is 29, I can figure out a. 180 minus 120 minus 29, 31. Cool. Alright, but let's think about this. Sine can be positive in quadrant 1 or quadrant 2. 29 is in quadrant 1, so I need to figure out my quadrant 2 possibility. In quadrant 2, b would be equal to 180 minus 29, which would give me 151. And if b was 151 degrees, and c was already 121 degrees, that means that a would have to equal negative 91 degrees, which we are going to reject because you cannot have negative angles, right? No imaginary angles that I know of that have been created. So we are going to reject this, so therefore there's only one triangle. But you need to actually go through and show the second case. If you don't go through showing it and explaining why there's a problem, or at least rejecting it, or showing that you get a negative angle measure, you're not going to get full credit. Make sure you do both cases. And last but certainly not least, number 15. 15 gives us a ladder that is 15 feet long, and it is placed so that it reaches from the ground to the top of a vertical wall that is 13 feet high. So let's draw my picture. Remember, in math class, we live in a perfect world. Here, I do know that I have a right angle. All right? They tell me that my wall is 13 feet high. And they say that my ladder is placed so it goes from the top of the wall to the ground. Alrighty? And remember, since this is math class and it is a wall with the ground and the ladder, it does make a right angle. Part A specifically says to use the law of sines to find the angle that the ladder makes with the ground. So that would be this angle right here. I'll call it theta. Alright? You cannot use SOHCAHTOA for this. I mean, you could, because it is a right triangle. Alright? But it explicitly says that we have to use the law of sines. So if it says use the law of sines, you have to have this proportion somewhere in here. Alright? So the sine of theta over 13 will equal the sine of 90, alright, this is a right angle, over 15. Cross multiply. Divide by 15. Which, if you put this in your calculator, you're going to get that sine theta is equal to 13 over 15, right? Because the sine of 90 is 1. Not done yet. Need to do inverse sine of both sides. Alrighty, in your calculator, inverse sine 13 divided by 15, you're going to get about 60 degrees. Alright, so this would have to be 60. So that's the answer to part A. It said it wanted to the nearest hundredth. JK lols. Alright, that's what I get for not reading the directions. So to the nearest hundredth, that would be 60.07. Alright, degrees. Alright. Then for part B, they ask, is there more than one position for this ladder? Alright, well if you think about it, the ladder and the wall make a triangle. So what it's really asking me, is there another triangle that I could make with these measurements? Well, let's figure it out. As of right now, I've got theta being 60.07. So I could find out that other angle. This one would have to be 29.93, right? Alright, well, let's figure out my quadrant 2 possibility. That would be 180 minus 60.07, which would give me 119.93 for my theta. Okay, and if my theta was 119.93, what would my other top angle have to be? Well, that means that this angle would have to be, so I'll do this in blue, 119.93. If that was the case, this top one would have to be negative 29.93, and we can't have negative angles. So we would reject this, and we would say only one position possible, because there's only one, I cannot stop. Oops. Only one position. There we go. Okay, so just a different way of asking how many possible triangles. You do have to show the second case, and you do have to show that it doesn't work. Alright, I'm going to say it again. You have to show the second case, and you have to show that it doesn't work if you're going to get full credit. And that is it. We are done.